All right, here's the solution to 8.2, number 31. So in this case, we are asked to find the volume of y equals sine of x, the first arch, and y equals 0, and to rotate it around the x-axis. So as always, we would first start out with a sketch. Here's sine. We know it's a period of 2 pi. So the first arch, which is what we are asked to rotate, goes from 0 to pi. So just the yellow region right here. Here we're asked to rotate it around the line y equals x. So in this case, I can see that my rotation, my axis of rotation is in fact one of the bounds of the region. So I'm going to get a solid circular cross-section. My cross-sections are perpendicular to the x-axis, so I'm going to be using dx. So I need everything in terms of x. So I'm integrating these little circular discs, cylinders, that are going to have area pi r squared, and the thickness is dx. And I'm going from 0 to pi because I want the first arch. So that's going to be 0 to pi, pi r, and the radius in this case is going from the x-axis to the curve sine of x. So that's a distance of sine of x, so r squared would be sine squared of x dx. At this point, you can integrate by parts or using the table. And when we integrate from 0 to pi, pi sine squared of x dx. And again, either way is fine. So if you look on the table or you can do by parts, you get that the antiderivative here, we still have the pi, and it's going to be 1/2 times x minus sine of x cosine of x, all evaluated between 0 and pi. So when I substitute that in, that's going to be pi over 2 times pi. Sine of pi is 0. And then when I plug in 0, everything is 0. So that's pi squared over 2. And they suggested rounding to the nearest hundredths place, so that would be 4.93.